Hey Ravens, welcome back. Time for electron configuration. Let's get started. Okay, quantum theory. Principal energy levels, also known as just energy levels. The region which is a certain distance from the nucleus where electrons have a larger probability of being found. We also call them electron shells. The energy levels, shells, principal energy levels, same exact thing. There are 7 of them. Notice on your periodic table how many periods are there? 7, one for every energy level. And they each have a certain number of electrons that can fit. You recall from 8th grade, you learned the first energy level holds 2, the second energy level can hold 8, the third energy level can hold 18, and the fourth energy levels and on can hold 32. Today we're going to show you why that is. Okay. Energy levels and sublevels. There's an S, a P, a D, or an F. Okay. In order of increasing energy, S has the lowest energy, F has the greatest energy. P and D then are respectively in the center. I have a bit of a car analogy I like to do. In the binder, we did the boarding house analogy. Here's just another one. It's filling up the car with passengers and drivers. The S sublevel, think about it like an economy model car. Think that little 2-seater smart car that gets good gas mileage. Okay. The P sublevel is a mid-sized sedan. In my mind, I envision the Olds Cutlass that my mom had when I was a kid with the big bench seats in the front and the back, held 6 people. The D sublevel is more of a really large SUV along the lines of like a Cadillac Escalade because you're holding more people. And then the F sublevel is more of that full-size passenger van or those small school buses. Okay. All right, energy levels and sublevels. Each energy level has a specific number of sublevels. Here you go, not hard to figure out. First energy level has 1 sublevel. It's a 1-car family. Second energy level has 2 sublevels, an S and a P. It's a 2-car family. Third energy level has 3 sublevels, S, a P, and a D. It's a 3-car family. And can you predict the fourth one? Fourth energy level has, hooray, you got it, 4 sublevels, sorry. Fourth energy level has 4 sublevels, the S, the P, the D, and the F. It's a 4-car family. So, and we've maxed out. So the 5th energy level, 6th, and 7th all have 4 sublevels as well. Okay. Each sublevel holds a certain number of electrons. So, S sublevel has 1 orbital. Remember 1 box in the boarding house model? It had 1 set of bunk beds for a maximum of 2 electrons. My car analogy, it's the smart car that has room for 2, a driver and 1 passenger. The P sublevel has those 3 orbitals. Remember the P rooms, the pink rooms in the boarding house? There were 3 bunk beds for a total of 6 boarders, 3 orbitals for 6 electrons. This is my Olds Cutlass with room for 6, 3 in front and 3 in back. Okay. The D sublevel has 5 orbitals and can hold 10 electrons. This is the Cadillac Escalade. You need to stretch your mind on this one a little bit because it doesn't really hold 10 people, but it's a big car and it gives the right illusion. And then last we have the F sublevel, 7 orbitals. It can hold up to 14 electrons, and this is the school van or the short bus that has room for 14. Configurations. Okay. Orbital notation. Coefficient is the energy level, so there's a 1, a 2, a 3, 4, 5, 6, or 7. The orbitals always lowercase, S, P, D, or F. And then up at the top, the superscript. The superscript is the number of electrons in that orbital. So if it's an S orbital, that number cannot be higher than a 2. P orbital, it can't be higher than a 6. Get the idea. Okay. Here we go, 3 rules. The Aufbau principle, fill the lowest energy levels first. Okay? But it's not in numerical order. You learned that in the cracking the code activity for the periodic table. Okay? Energy levels do overlap, starting with the 3rd and 4th energy levels. Okay? Here is a predicted, this is a path. You can follow the yellow brick road, the black lined arrows. Okay, maybe it would be follow the black brick road. Anyway, if you do that and follow along on your periodic table, you'll see this pattern. The idea is be able to read it off your periodic table. Don't memorize it, read it off the periodic table. Okay. All right, here is the order in which they fill. We can look at it like this. A car caravan is with my car analogy. So the one car family, energy level 1, fills their smart car with their 2 electrons. Then the 2 car family, the second energy level, fills, and we're over here, with the 2s, fill their smart car. Then they fill their Olds Cutlass, and their cars are all filled. Now we move on to the 3 car family. They fill up their smart car, then they fill up their Cutlass, okay? And then notice here, the 4 car family jumps in and fills their smart car first because they are more efficient. Then that Cadillac Escalade of the 3 car family will be filled. And then we get the 4th row, the 4th energy level, filling up their Olds Cutlass. You get the idea. Don't memorize this. Read it off the periodic table. And if you are still not able to figure out how to do it, please come see me or see someone who does know, who has figured it out. Please, please, please. Okay. Next rule. So we did off-bow's principle was energy levels fill lowest energy first, then going up. Pauli exclusion principle basically states an orbital can only hold 2 electrons, and those 2 electrons have opposite spins. Okay. Hund's rule, this is the getting on the bus rule. Everybody wants their own seat before anybody doubles up. Okay. There we go. Let's just look at what it looks like. Okay. 6 electrons fit into the 3p orbitals. Each one gets a single electron first. Here they go. 1, 2, 3. Does not matter if they're all down arrows or all up arrows, but they all have to be going in the same direction. Here come the other 3 electrons coming back in the opposite direction. 1, 3, 4, 5, 6. Okay. All right. So here are some hints. I don't think that this really applies since we're focused on being able to read the periodic table. Okay. But each orbital must be filled before moving on to the next orbital. And you can look at those examples at your leisure. Pause if you need to. Okay. Every energy level, the p orbitals are always followed by the s orbital, the next higher energy level, because when we get to the 3 p's, they're at the end of the periodic table. You go to the beginning of the next row, and that's an s orbital. All right. Copy this down, go to this website. It's a great hands-on interactive activity for filling electrons into their orbitals, and very visual. Cool place to go. All right, this is really neat too. I wanted to show to you, this is a diagram showing what all of the orbitals of each sublevel look like. So here's your 1s orbital. Remember, it only holds, first energy level, only holds 2 electrons because that's the only orbital there is. 2s, we're now on the second energy level. Here's the first energy level, second energy level. Then we also get into our p orbitals. There are 3 different shapes of p orbitals. Okay. Then we get into the 4th row, and we have our 4. There's 1, 2, 3, 4th s orbital. Okay, we're going back and filling up the 3ds. There are 5 orbitals in the d sublevel. These are the shapes of the 5 orbitals. And then you go to your 4 p's. Here are the shapes of the p orbitals. Okay, take a look at this, pause it, look through it. This is really cool. All right, I like it. And again, you can see energy level 1 holds a maximum of 2 electrons. Energy level 2, here's 2 electrons in this one, and this one holds 6. 2 plus 6 is 8. The 3rd energy level, you have your 2 here, plus you have your 10 when they fill down here, plus you have your 6 there. That's your 18, right? 2, or here's 6 and 10, 16, 17, 18. Fourth energy level, all right, we get the S, the F, the D, and the P. And there is your 32. Okay. All right. Here's a cool summary table, the number of shapes there are, the maximum electrons it holds, and where it starts, which energy level. Okay, just a little bit of a summary there. All right, what do orbital diagrams look like? We fill lowest energy level first, putting your 2 arrows. This was phosphorus with 15 electrons. First, the 2 go into the 1s orbital. Okay, opposite spins. There you go, 2 more into the 2s orbital. Next in energy will be the 2 p's. Then going up, we get the 3 s's. And then we get the 3 p's. The last 3 electrons go into the 3p orbitals. Okay, each is into a separate one based on Hund's rule, and they all spin in the same direction. So there are 3 unpaired electrons. Here is the electron configuration. Configuration over here, orbital diagram here. Configuration, orbital diagram. Understand the difference in the 2 words. All right, here it is written out with a review. Okay, what element is this? Can anybody guess? It is zinc. Okay, at least I'm pretty sure. I'm doing that off the top of my head. All right, and this is it. We end here for today. So have a great day, Ravens, and we'll see you back for part 9, Periodic Trends.